Here again we have a question paper. I'm not sure if you can access. So this is a question paper which was done in 2009. Building, civil. So during those ages, this paper was done as a tape exam. So this question was done at the end. It was done at the end of the 3 years. So I had gotten it somewhere, but I will upload it so you can go ahead and see. So this is a survey question for curve ranging, so setting of curves, and let's go ahead. So this was question 5b. So figure 2 shows two straights, PQI and RSI, whose bearings are 47 degrees, 35 minutes 45 seconds, and 347 degrees, 25 minutes and 40 seconds respectively. So the straights are connected by a straight line QS. If the coordinates of Q and S are given, so these are the coordinates, so the northing and the eastings. So the coordinates for Q, they have been given, and for S, they have been given there. You can look at them. So the question goes by, so calculate the first, the radius of the curve that will be tangential to each of the line. So the radius of the curve which will be tangential to each of the line P, Q, QS and RS. Then the second, calculate the coordinates of T1 and T2. So this was a total of 17 marks, and they had combined. So this is a curve ranging question, but also they have gotten a concept from traversing. So they have mixed both question, which is interesting, in order for you to understand which has been done and for you to calculate. So here is the diagram. So we have P to I, R to I. Then here we have the Q, S, that we have been given the coordinates for. So the coordinates, they have been given here. So the northing and the easting, those are the control points that were gotten. Then here we have T1 and T2. Then here we have center O. So we go ahead and see the solution. So I have calculated here the solution. So I went ahead and sketched my own. So this sketch comes from the concept that we have been told here. So in order for the radius of the curve to be tangential to each of the line PQ, QS and RS, that means the circle will have to touch all those points. So I've gone ahead. So in order for the radius to be tangential to, so this is PQ, in order for it also to be tangential to QS, and also for it to be tangential to SR. So tangential, so that line, so when a curve meets a straight line and it forms a 90 degrees, it will be tangential, which we have been told here. So I go ahead and draw my curve. So my curve will be here. So this is just a simple curve. So my curve will be represented here. So that will be my curve. See, it has been drawn there. So my curve will be a straight line. So from T1 to T2, I go ahead and illustrate the diagram. So we have been told here in our question, so the angles that we have been given, so the bearing of PQI is 47, 35, 45, and the bearing of QSI is 300 and 47, 25, 40. So I go ahead. So I need to find the bearing that is here. So if the bearing of that line, so if my bearing is 47, so the angle of the bearing will be from the northing, so that bearing will be on top there. So if my bearing is 47, I need to find the angle that remained here, the internal angle. So I will subtract 90 because the value that we have been given is found in the first quadrant. So I'll subtract 90 and I will find my remaining distance at the angle that is here. So angle Q will be 42 degrees 24 minutes 15 seconds. Then here we go ahead and we do the same. So if this was the bearing also of that line, it means it cuts there. So if it cuts there and the last of my third quadrant in the compass was 270, so I need to find the angle that has remained here, which will be equal to this internal angle there. So I go ahead and subtract. So this is 347 degrees 25 minutes 40 seconds minus 270 degrees. So when you subtract, to go ahead, my answer will be 77 degrees 25. So it will be 77 degrees 25 minutes 40 seconds. So that will be my angle, my internal angle there. Having calculated that, so additional of both those angles, subtract by 180 degrees, and I will have found my angle of intersection as 60 degrees 10 minutes 5 seconds. So if this is my angle of intersection, so my deflection angle will be 180 minus the intersection angle that we have gotten here, and my deflection angle will be 119 degrees 49 minutes 55 seconds. So that is my deflection angle. Then I go ahead, so I need to find the distance that we have here. So I go ahead and use a simple mathematical formula, because here we had been given the measurements. So I go ahead, so from so let's go. So the radius of the curve that will be tangential to each of this line. So I need to go and find my lines. From my lines, I'll have already calculated. So I go ahead, so I need to find the length of QS. The length of QS, I go ahead, so I just want you to, so I need to find this length. So the length of QS, my length of QS will be, I go ahead, so this is a simple formula found in traversing. So in order for me to find the length of QS, I go ahead and use the coordinates that have been given here in this question. So I go ahead and subtract the coordinates for the easting. My answer, I square it, then I go ahead and subtract the coordinates for the northing, and my answer, I square it, then the final answer will have an additional. So we go ahead, so this is the coordinates for the easting. So I use the coordinates for the easting. So this is 3190.54 minus 2900. Here we have it, and then my answer, I find the square root of that, then plus the coordinates for the northing. So this the coordinates for the northing, So if the line is QS, so I start with S, so this will be 2807.33 minus 2681.93, and my answer, I square it. So after having the additional of this and this, which has already been squared, additional of those, so I find the square root of the answer that I have. So the square root of that answer, and the length of QS will be 279.42. so this is the length of QS. So having gotten the length of QS, I need to find the length of the others. So if I have the length of QS, that is from here to here, I can use the mathematical concept in order for me to find the length of QI and also for IS. So I go ahead and write my formulas. So QI, so Q to intersection over sin, the angle that I had gotten there, so sin 77 degrees 25 minutes 40 seconds. So we compare, I had done an example of this, so you compare the value that you want, so the value that you want by the opposite of it. So here the angle of Q by the opposite of it will be compared to the value that we have here by opposite of it that we have calculated there. So this is the formula for the sine rule, so you can go ahead in math and you look at that. So this is the formula that we have gotten from the sine rule, mathematical concept of the triangle, concept of finding the angles and the distances. So QI over sine 77 degrees 25 minutes 40 is equals to the length that we have gotten over the sine of the angle that we had there. So my QI becomes 314.38 meters. Then I go ahead and calculate for SI, so that is the distance from intersection to point S. So intersection to point S, that distance there, so that distance will be Q, so SI over sin 42 degrees, that is the angle of the opposite. So this angle is found at Q, so that angle is equals to what we have already seen there. So that will be the length that you have gotten for QS over sine the angle of intersection that we had there on top. So SI will be 217.21 meters. That will be my SI. So having found that distance, I want to find the, so here in our, so we need to find the radius of the curve, and in order for me to find the radius of the curve, I need to compare it to something. So I go ahead and I draw here. So the length of QI will be that, and also the length of IS will be that. So I go ahead and compare the value. So I use the maths that concept that we were taught, so the Socator rule. So Socator rule, so I go ahead and use the sine. So sine is equals to opposite of a hypotenuse. So I already have my angle here. My angle here is 42 degrees 24 15. So sine that angle is equals to opposite. I need to find this distance, so that will be my opposite over the hypotenuse, which I've already gotten, and that I needed to prove it if it was right. Also you can go ahead to the other side. So sine the angle that we have here, so sine 77 25 40 is equals to opposite, which we were calculating here. So opposite over the distance that we have been given here, which is the hypotenuse of that. So when you do for both of them, your answer will be 212 meters. So 212 meters, that is the distance when you go ahead and in the diagram, because this curve had touched this point, so this will be the apex distance, or the external distance from the intersection to the center of our curve. So that is the apex distance, and we have already calculated the apex distance here. So this is the apex distance that we have already calculated here. So the apex distance will be 212 meters. So I compare this apex distance to the formula. So apex distance is equals to sine, so that is sec theta over 2 minus 1. I had already calculated my deflection angle here on top, so I had already calculated the deflection angle. My deflection angle was here, so here is my deflection angle. So we use that deflection angle. So I compare, so apex distance, which is 212, is equals to r, which we are supposed to calculate. So r into bracket sec the deflection angle divided by 2 minus 1. So you find the cos of the half of the deflection angle, then you find, after finding the cos, you find the inverse of the cos. It will represent the sec. Then your answer, you subtract it by 1. After subtracting it by 1, and you find the radius as 213.08 meters. So here is our answer for the radius. So we have already calculated the radius as per the question. So they needed the radius of the curve, which is tangential to each of the lines. Then we go ahead and we calculate the coordinates of points T1 and T2. So the coordinates of those points, we go ahead. So here we need to go back to the formula of tangent length. So tangent length is equals to r tan theta 2. So we calculate our tangent length, and after calculating our tangent length, so our tangent length is equals to 367.82 meters. So this is the distance of the tangent length. So this is the distance from T1 to intersection of the curve, and I have already calculated earlier the distance of Q to I, or I to Q. So I need to subtract the tangent length from this distance in order for me to get T1 to Q. So that is the distance that I want to calculate, and that distance is the distance that I will use in order for me to get the coordinates for the easting and the northing for T1. So when I subtract the tangent length minus the length that I had calculated earlier, and my answer becomes 53.44 meters. Then I go ahead and do the same for T2 to S. So the tangent length remained the same, but the distance that I had calculated earlier, so from S to I, the distance was different. So I go ahead, so SI here it was 217.21. so I subtract that distance and I get my distance from T2 to S. So that is the distance that I'm getting. So that distance will be 150.61. so that is my distance. So this distance, it's a little bit higher, which is just as correct. So that distance is higher. So I go back to traversing. So in traversing we had certain formulas that are found, and those formulas we can use them. So let's have a look at at a book. So this is elementary survey. In this book we can see a little bit demonstration of the formulas that we are supposed to use in order for us to continue with this exercise. So there are all the formulas that I had applied. So I got them from this book, and the formulas are used to finding the coordinates of the northing and easting, and in those formulas we compare everything with the length. So this is just a book you can download in the internet or in the library, and you can look at the book. It shows a lot of examples and a little bit explanation in the formulas that I've applied in this section. So we are going to compare the length in order for us to get the eastings, which is the departure, or even the northings. So we are going to have a look at the book. You can download it or you can see it in your library, and the formulas are a little bit simple, but we are going to use another book in order for us to have a similarity and a comparison from where our points have been gotten. So here in our second book, the WCB are used as above. So the sign of the cos and the sine values will alter automatically. So the cos and the sine values will alter automatically depending upon the quadrant. So the sine and the cos will be dependent on the quadrant in which the value will apply. So here we go ahead. Use the length available, that is 53.44, is equals to the eastings that we had been given for Q. So that is the easting that we had been given for Q there, that is 2940.84 minus the easting that we are looking for over the cos theta. So that is the angle that we had earlier calculated. So that is the angle found there, similar to the one that was on top there, because all the lines they lie at a perpendicular to each other. So our answer will be that. So that is the easting for x. We go ahead and we calculate the northing for T1. So y represent the northing, x will represent the eastings. So we have already there the northing given, so that northing minus the one that we are looking for over sine the angle we already have it there. So our answer for the northing becomes that. So that is our northing, and the previous is the eastings. We go again to our second value. So here we have to calculate the coordinates for T2. So we compare the measurement that we have been given there. So that is the length is equals to the easting of S. So we minus the and our answer over cos the angle that we are calculated there, and we get our final easting coordinate. Then we go to the northing coordinate. So the northing coordinate will be, so the length given there is equals to the coordinate for the northing that we have been given for S in the question. So that is the coordinate for the northing minus the coordinate that we are supposed to look for over sine 77 25 40, and our coordinate for the northing will be that. So I've gone ahead and drawn a table there. So I've written the coordinates for the easting and the northing. So depending on how you are taught, it's different. So we have answered the coordinates for the T1 and T2, both for northing and for eastings. Having done that, we go back. So these two books are very important. So that book is for elementary surveying, an introduction into geomatics by Charles D. That is our reference number 1. Then our reference number 2 is surveying 6th edition. So this is surveying by Bannister. This book is found in the internet, and you can download it too. or you can go to the library and find more information about it. So that will be all, and there are our coordinates. Thank you.